Thank you very much. Thanks for attending here, and thank you for the organizers and our AV support here. So today I'm going to go through GeologicAI, what our offerings are, how our technology is different and how it leads to faster decision making, how we're assisting and improving core logging specifically as a use case, and how that leads to better outcomes for projects. So what we're doing is basically empowering clients to make more confident decisions faster by supplying them with data rapidly from core scanning to produce that very rapid data turnaround, full quality control. Then goes to supporting with information. So we build off of those data products with advanced products that are developed through machine learning applications that we can deliver to anywhere in the world, essentially, through cloud-based platforms. And then we support that with geoscience expertise from our subject matter experts. And it's not just scanning either. We have multiple business units that lean into geostatistics, mine planning, geometallurgy as well. So speaking to that, we have two major offerings, that RKS on the left there and RMS on the right. So those are well established across the industry already. They've been around for quite a while. Resource Knowledge Systems does more of the core scanning and towards the data prep and interpretation into visualization and manipulation of data in 3D, and then we sort of lean more towards the RMS side of things, where RMS is more about modeling solutions, targeting, and mine planning solutions as well. Our XS, which is the exploration strategies, you can see at the bottom of the slide there, that is a new operating unit that just started up and around in November, and they have partnered with Edge Copper on the Zonia project in Arizona to bring that entire pipeline of support to junior companies that need it for developing their resources and their mine plans. So in this talk, I'm just going to concentrate on the RKS on the left-hand side there. So this is our new, brand new scanner. We just rolled out with it actually at this conference here. So this is brand new. The previous version of scanner that's already been deployed on dozens of sites worldwide looks quite different, but it has the same basic data products, or sensors, I guess. So we have continuous line scan XRF. We have hyperspectral through SWIR and Wiener. We have LiDAR, that's more for geotechnical and also for path planning and structure. We have RGB imagery, of course, down to hand lens magnification on the core, and that's both dry and wet, so we can do wet photos directly in the sensor trailer. And then we also have magnetic susceptibility being rolled out onto a few projects. On the top right, you can see LIBS. LIBS is a new offering for us. We just acquired Lumo Analytics in December. So the LIBS method, if you're not familiar with it, it basically uses lasers to do very, very, very small hits on the rock, and you can actually get a lot of, you can get all your element compositions, including light elements, so it's very useful for lithium, boron, those sorts of light elements that XRF can't do. So we're starting to integrate that now as well, and those are being offered as a sort of portable solution for a lot of different projects now. So both of these are actually on display, so you can come visit us at 552 if you want to see both of these in action. The major benefit that we have through our scanning method is the integration of sensors. So we are basically sampling, we have 4 different, and now 5 once we integrate LIBS, parts of the EM spectrum that are being sampled here, but these are all being co-located at high spatial resolution on one part of the rock. And so when you do that, you get these multiple data sources stacking, and you can actually get more advanced products because you're building it with more data from independent methods. So we have this co-located independent data. You can start to get that more full characterization of the rock, and so you can lean more into advanced things like geometallurgy and collect data that actually serves those purposes too. The other thing that's really critical is QC, of course. Confidence starts with QC, so we can't make decisions unless you trust the data. We definitely want to make sure that's the case, so we scan certified reference materials. We have matrix matched reference boxes as well that are specific to each individual site. We have a FleetWatch monitoring system that monitors every single scan, instrument constantly. And then we also have inspections, audits, of course, and it's all backed up by SMEs. So we have geologists and experienced geoscientists that are examining every single product that goes out the door. So this is a selection of the advanced products. A coworker of mine said that giving geologists time to do what they do best, lick the rocks, but I prefer to say interpret the geology. This is supposed to, what we were trying to do is provide the geos with all the tools that they need to make good decisions on the core. So you have all those primary data products, but you also have these advanced machine learning driven products. We have mineral maps, so these are shortwave mineral maps of not just the most dominant mineral, but we also unmix at the pixel scale, and so you can get abundances by each individual mineral. We have calibrated XRF, so you don't have to just use XRF counts. We can actually report different elements from the XRF in ppm or percent. We have RQD for more geotechnical characterization. The LEP with the low element predictor, which is sometimes called the gold finder. A lot of projects obviously want to know what gold grades or deleterious element grades might be in the rock rapidly. They want to know that soon. And this basically takes dozens of independent variables and predicts the concentration of those elements. And so that allows, for example, on a gold project to immediately know your gold grades, or at least have an idea of your gold grades. And so you can make those decisions on an exploration hole, for example, much quicker. The autolith does the similar thing, takes all those independent variables and predicts what lithology it is. So that's a real help for core logging, leads to a lot of consistency. And then we also have the sulfide finder, which finds and maps sulfide minerals and reports concentrations, grain sizes, and that sort of thing. So I'm going to turn now to core logging. Every project is somewhere on this continuum. We still have a lot of projects out there that are doing paper logging, but obviously that's a little bit difficult to control for consistency and standardization. A lot of sites have now moved to digital logging, where you have the advantageous sort of connection with the database. But really, what you're doing is you're still filling data out in a table. Like this is basically sort of like a spreadsheet that you're filling your data into. What I'm going to talk about and what we support is core scanning supported digital logging, which is the third one on there. So we are allowing the loggers to interpret the geology based on having a lot of data at their fingertips. And on the very right-hand side, basically nobody is doing this yet, AI-derived core logging, but that's something that we are getting into, and we've actually presented a case study on this at a different conference, but we at some point want to go straight from the data source straight to domaining, whether it's for resource domaining purposes, whether it's for metallurgical domains, things like that. So you can ask us about that at the booth as well if you like, but I'll be concentrating on the production side of things that we're doing right now. So like I said, all these data and products are being delivered to a cloud-based platform, and that is the digital core table. So that is, I can't give you a demo here obviously, but we have this running at our booth as well if you want to come see it. But this is a cloud-based visualization platform. All the co-located data is aggregated. It's all depth corrected accurately, so you can see exactly what depth everything is at. On one side you will have strip logs, so you'll be able to see the downhole variability of all the data, and on the right hand side you can see, you can kind of see on the right hand side in that image, that's an overlay directly on the core photos. So you can get that core photo view, you get the strip log view all together, and it's all at your fingertips. Taking that one step further, there are a number of projects now that are doing logging on the core table, because if you have all that data, you might as well have your geos logging using the same platform. We know that geos are not consistent, so you give them as many tools as you can. When you're logging on the core table, you can just paint directly onto the core, you can paint onto the strip log, you provide intervals, the autolithology is there to report what lithology it thinks it is. You can either say no, or you can just go with it. This has been a real huge advantage for consistency on a number of sites. Currently, as of this week, we're logging about 2,000 meters a day on 3 continents right now. So it's being picked up, and we're actively developing the software to be faster and more user-friendly as well. Another thing that we can do once you've got all of your data and all of your logging on the core table platform is you can do your sampling there too. And for that, we have a tool called the auto sampler. I mentioned there's a product called the LEP, or the low element predictor, for gold. This on the right-hand side are 2 drill holes where we had a predictor for a grade of the metal on a project, and you can see on the right-hand side of both of those holes is the predicted grade, and on the left-hand side is what came back from the assay lab once they had, tagged it and cut it and sent it off, and weeks or months later they got their assays back. And you can see the LEP did a fantastic job. It's not perfect, but it did a fantastic job of predicting those grades on that left-hand drill hole. On the right-hand drill hole, you can see there's selective sampling that was done on this project. And so the geos were tasked with trying to sample anything that was a yellow color or higher. You can see on the top 2 intervals on that drill hole, they didn't do a great job. They oversampled that area. They thought there was something there really wasn't. And on the bottom, underneath that interval of mineralization, you can see there's some intervals of yellow there that should have been sampled that weren't. So we have some oversampling, we have some undersampling. And what we can do when we have all of these tools now is just tell the auto sampler, okay, I want to sample these grades, and just click go, and it'll do it for you. So on a gold mine in Ontario, we saw that the auto sampler reduced the analytical costs by more than 50%. This is on a site that had selective sampling, and it also reduced those missed intervals by over 80%. So there was a huge benefit to them using that. The other thing that we can also program into the algorithm is all of your QC. So you have QC samples, duplicates, whatever, sample break rules. If you have a break in lithology and you don't want to sample across it, you can program that into, and it just one button push for the geologist, and it goes and it's accurate. The other thing that we are now doing on a couple of different projects is remote logging with the core table. So as you can see, like with this cloud-based platform, everything at your fingertips, you don't actually necessarily have to be there. I mean, I've logged tens of thousands of meters of drill core on the core. I understand the value of being there, but on some sites, maybe you have really data-driven workflows and you don't really need the geologist on the core. Maybe you have really challenging logistics, it's very expensive, or there's safety concerns, high altitudes, things like that. Projects like that can benefit from taking this logging and moving it off-site. And that can either be the client's team or it can be our geoscientists. We have people working daily on doing core logging remotely. And again, you're preserving, it's auditable from anywhere, and it's also auditable not just the interpretations that the geologist makes, but also all of the supporting data that went into those interpretations. So you can always relog, you can always question and go back to things afterwards, and you can scale too. So you scale up, you scale down, drill programs move, drill programs start and end, and you can scale it this way too. So here is another case study of the value of that consistent data. On the left-hand side, this is from a gold mine in Quebec that we've been working on for quite a long time. Traditional lithology logging, over years and years and years of logging on the left-hand side. Very, very similar looking units. Very difficult for them to distinguish them. So you can see it's a bit of a dog's breakfast of lithologies just being sort of logged there. On the middle is the same lithology, same drill holes, but the lithologies have been classified using our scan data. So our scan data has allowed them to distinguish all of these different lithological units. And on the right-hand side, you can see the geomodel that was developed using that same data. And especially that blue unit, you can see there that's sort of swirling around in the cross-section there. That is a barren unit, and that allowed them to define where that barren unit is and plan their stopes around it. So you have immediate, less dilution, you have immediate impact to your mine and your recoveries. Lastly, just want to plug RMS one more time here. I just sort of touched on it, but as soon as you start leaning into the modeling side of things, into the geostats, block models, RMS is a fantastic partner. They are being used by mid-tier to super major companies across the industry. RMSP is their main offering, which you may have heard of, but they're now, you can see this at our booth as well, they're now demoing and rolling out a 3D visualization platform for modeling and viewing called AMP. And they also have a drill hole optimization tool that they are also offering, which allows you to basically fill in, if you're doing an infill drilling program, to get the maximum uplift for the minimum amount of meters and dollars spent. They also do training and support, so they're a fantastic team. So if you have any resource tools or resource needs, please come talk to them. Okay, so I know that was very quick, but yeah, like I said, we're at 552 over in the main trade show, and thank you very much.